Howdy, howdy, this is Mr. Potter. Today we're going to be talking about Vieta's formula. Vieta was a French mathematician, lived in the 1500s, so 16th century mathematician, and he's dealing primarily with the relationship between the values of the roots, or the solutions to a polynomial equation, and their sums or their products. And so I've got a very simple one here. I've got x minus 4 times x minus 3. And that means that if I was to set this equal to 0, I would have solutions x equal to 4 and x equal to 3. And if I take a look at this 4 and this 3, I see several things here. One, if I were to take 4 plus 3, I know that I see this 7 here, and I see that really nice relationship. And secondly, if I were to take 4 times 3, 4 times 3 gives me this 12. In other words, if I look at the values in my polynomial, I'm going to see the sum and the product. And it's going to be off by a sign, so maybe positive, maybe negative, but there's even a predictor for that. Because I know that x squared is normally a positive term, because whenever I square a positive number, I get a positive. If I square a negative number, I get a positive as well. And so I could think of it, okay, if this is positive, then this value is negative, and this value is positive. These signs kind of alternate from my highest degree. And so if I were to take this first root plus the second root, then 4 plus 3 gives me the 7. So in other words, the sum of the roots is really equal to the opposite of my b coefficient, my linear coefficient, divided by a, my quadratic coefficient. And similarly, r1 times r2 is going to be equal to whatever c divided by a is. In other words, I can see the relationship between the sum and the product of the roots given the roots from my polynomial. And what's nice is because that actually means I can take a quadratic and change it into a system of equations to come up with this relationship. And of course, I have this divided by a, but really if I were to have something like 2x squared minus 14x plus 24, this is going to have the exact same solutions because I could factor a 2 out of it. So let's take a slightly more complicated situation. Here I've got 2x minus 3 and 4x plus 5 as my binomials. So this is going to have my first solution is going to be x equals 3 halves, and this is going to have my other solution of x equals negative 5 fourths. Now, if I was to take r1 plus r2, I'm going to be adding 3 halves plus negative 5 fourths, and I would want a common denominator. So this is going to be 3 12/8 minus 10/8, which is going to give me 2/8. And notice that I've got the 2 here, and I've got the 8 here. So it still holds that my sum is going to be equal to negative b over a, which is really 2/8, or 1/4. And similarly, if I look at my product of my roots, multiply those together, I'm going to have 3 halves times negative 5 fourths. And when I multiply, I'm going to get negative 15 over 8. And again, I see the negative 15 here. I see the 8 here. And so my product is equal to c divided by a. So this is really nice when I have quadratics. I can use Vieta's equations to come up with the sum of the roots or the product of the roots. And this does hold for higher degree polynomials. So let's say I've got a cubic here. Let's say I've got x cubed minus 2x squared minus 11x plus 12. And again, the idea here is I'm going to start off with my first term being positive. My highest degree is going to be positive, and it's going to alternate all the way down. So my sum of my roots is going to be equal to negative b over a. My product of the roots is going to come out to be this last term divided by my first term, because 1 times 3 times 4 is where I get this 12. So my product of the roots is going to be negative d over a. Again, because of this positive, negative situation. So if I take a look at this, keep in mind that I have a solution here, x equals 1, x equals negative 3, and x equals 4. So if I were to take the sum of these roots, I'm going to have 1 plus negative 3, that's negative 2, plus 4, that's going to be positive 2. So the sum of my roots is 2. But if I take a look at my formula, I'm going to have the opposite of b divided by a. Well, that is 2. That works out really well. And similarly, if I were to multiply these, I'm going to have 1 times negative 3, which is negative 3, times 4 gives me negative 12. So my product of the roots is negative 12. But if I take a look at this formula, I want the opposite of d divided by a, which is negative 12. Vieta's formulas are really interesting formulas that we can use to deal with the relationships between the products of the roots and the sum of the roots whenever I'm dealing with any degree of polynomial. My sum is always going to have to deal with this 1 degree lower term. It's always going to be negative b over a. My product is always going to have to deal with the last term, and so you're always going to have to figure out this sign, but keep in mind that if it's odd, in other words, if the degree of my polynomial is odd, it's going to be negative. If I go back in all the other examples we had when my degree was even, this ends up being positive. So that's one way that you can work it. Have a great day.